You spend a week meticulously calculating every decimal point, only to have your stakeholder ask, "Just tell me, it is trending up or down?" Hi everyone, I'm Cleona, and I'm back. As my year's leading data team, I realized something critical. You can have the best data in the world, but if the human brain can process it in a second, it's useless. This up or down question isn't a lack of interest. It's a reflection of how we process information. And this highlights the functional gap between the raw data and a decision. Data visualization is a tool we use to close the gap, transforming the complex dataset into the format our mind can actually use it. Our eyes are the matter of the physical world. You look at forest and constantly see green. But here's the problem. Your biological sight is limited to the surface. You can see which specific trees are diseased or dehydrated just by staring at the leaf. Data is exactly the same. If I give you 10 pages of cell data across 34 provinces over 5 years, your brain will immediately hit the wall. Why? Because reading is serial process. You have to process one number at a time, like a slow drip of water. But according to a landmark MIT study, namely detecting the meaning in rapid serial visual presentation at 13 milliseconds per picture, the human brain can identify the meaning of picture in as little as 13 milliseconds. So we can identify the complex pattern in as little as 13 milliseconds, long before we even finished reading the first word of table. And this is the difference between the tree and flood of information. Data's visualization transcends simple legibility. It facilitates a cognitive shift from labor of serial process to efficiency of parallel pattern recognition. Instead of forcing your stakeholder read the forest, we use data visualization, let them send the fire. This is where I started realizing that we need to manage the bandwidth of human mind rather than presenting raw information. But theory is one thing, thinking and actions is another. To truly understand how this bandwidth content dictates our decision, we need to have a look at what happens when our serious mind is intentionally dictated by the data we read. In the data industry, there are famous wake-up call that prove why reading data is a dangerous game. It's called Anscombes Quartet. It perfectly illustrates the high-stakes gamble we take when you try to squeeze the mountains of data through a narrow cognitive draw. So let's put our bandwidth to the test with classical experiment. When you look at the force table, your brain is forced into serial processing. Read one digit, store it into short-term memory, and move to the next one. But our cognitive bandwidth for number is incredibly narrow. Most of us can hold only 7 items plus or minus 2 with our working memories of 1. Because of this limitation, we rely on summary statistics to simplify the story. We look at the mean, the variance, the correlation. In all for this table, all those numbers are identical. If you only look at straw of statistics, your narrow bandwidth processing concludes. These are exactly the same. We're compressing the amount of complex data into simple, deceptive points. But the moment we switch to the parallel processing of chart, the truth is revealed. Remember the 13th millisecond MIT studies? That is what has been right now. The visual cortex isn't reading dot, it's consuming the entire shades of data instantly. And that is when your high bandwidth system signal warning. They are completely different worlds. This first dataset showed a clean linear trend. The second revealed a hidden curve, just magic missed. The third one is being dragged away by a single high-leverage outlier, and the last one is a total anomaly. Anscombes Quartet is ultimately warning of what happening when data compression fails. It proved that statistics can give you the coordinate, data visualization gives you context. To provide a concrete example, my team audited a shipment volume forecast with mean absolute percentage error and wasted absolute percentage error appears stable and hovered within the standards of 10% and 12% threshold. In the flat spreadsheet, the model performance seemed optimal. However, the moment we geospatially map the variant in real life, the average is a mask. We identify a specific cluster where wasted absolute percentage error spiked to 50%. Without visualization, we would have treated this as statistical failure while wasting week recalibrating the model performance. That just wasn't actually broken. Instead, 10 minutes of visual inspection revealed the operational root core, that is strategic utilities of data land. It injures you wasn't waiting resources, solving the wrong problem. Developing high-level data visualization capabilities is about more than just aesthetic. It's about engineering the functional interface between raw data and human brain. And we continue to push the boundaries of how much we can see through data. We also must address the responsibility that comes with this power. So I leave you a question on data ethics. If data designer can detect your focus simply by adjusting the saturation of the bar chart, is that informative visualization or is this cognitive manipulation? I'd love to hear your professional perspective in the comments below. And that is the end of my video. Thanks for listening. See you in the next one. Wish you best.